So the first topic is carbonate compensation depth. Okay, CCD. This is not cafe coffee day, but the carbonate compensation depth. Okay, so the CCD is the depth at which the influx of calcium carbonate from surface water is balanced by its dissolution in the deep ocean water. Okay, so what this actually this CCD is the depth, or you can say a surface at a particular depth above which there will be deposition of carbonate, and below which there will be dissolution of carbonate. Okay, so in simple terms we can say it like this, that say this is the CCD depth, and say this is the water column here. This is the land surface. So what we can see here is that this is here we get to see precipitation of CaCO3, right? But here we get to see what? We get to see dissolution, dissolution of CaCO3. Okay, dissolution of CaCO3 and precipitation of CaCO3. Fine. So factors affecting the CCD is that water chemistry, higher level of acidity, that is lower pH, can increase the dissolution rate of carbonate minerals. Okay, so water chemistry is important because, as you know, that uh, lesser the pH, more will be the dissolution of calcium carbonate. Then temperature, so warmer waters generally enhance dissolution rate. Okay, warmer water also enhances the dissolution of calcium carbonate. Then pressure, high pressure at greater depths can affect the solubility of carbonate minerals. Okay, then latitude, so at equator CCD is higher, that is at 4,000 to 5,000 meters, than at polar regions, which is only at 300 to 400 meters. So at polar regions you will get to see more dissolution of calcium carbonate, as the CCD level is quite at higher level, whereas at the equator you will see more precipitation of calcium carbonate, as CCD is way lower. Okay, 4 to 5 kilometers below the mean sea level. So as you can see, the CCD varies. The actually the depth varies at different levels. Sorry, at different areas. Okay, depending on temperature, pressure, latitude, and water chemistry. So the depth of photic zones. So in photic zones, excess of photosynthesis plants decreases the CO2 level. Okay. So what is a photic zone? Photic zone is say about uh, just let me shift. Do I have a diagram of photic zone? Okay. Okay, so I'll just show you the diagram here. Say, so photic zone will be like this. Sorry. So this is the water level, and this distance is photic zone. Photic zone is the area which is lit by sunlight. Okay, it's called photic zone. Okay, so this whole area will be considered as a photic zone. It is usually up to 200 meters. 200 meters depth from the mean sea level. This is the mean sea level. Okay, MSL. So photic zone is up to 200 meters of the depth. Okay, right? So in photic zones, excess of photosynthesis. So in the photic zone, we get to have sunlight. So there will be a lot of floating plant bodies. Okay. So photosynthesis plants decreases the CO2 level. So as photosynthetic plants take CO2 for making their food and create alkaline environment which supplies more CO3 and CaCO3 get deposited. Okay, so more amount of photosynthetic plants on the ocean water on one water body, so more amount of calcium carbonate deposition will takes place. It will lower the CCD. Okay, and below photic zone, the acidic environment which supplies less CaCO3, so it dissolves CaCO3. So photic zones actually aids more um precipitation of CaCO3. Fine. Then the importance. So the CCD influences the distribution and preservation of calcium carbonate-rich sediments in the ocean. Above the CCD, carbon sediments can accumulate and form limestone deposits over time. So above the CCD, we get to see carbonate deposition, whereas below the CCD, we get to see carbonate dissolution. Okay. Then also paleoclimate and paleoceanography. So studying changes in the CCD over geological time helps researchers understand past oceanographic and climatic conditions such as ocean acidification events and changes in ocean circulation. Okay, this is the application of understanding CCD of past environments and environmental impact. So changes in the CCD today due to anthropogenic carbon dioxide emission can affect marine ecosystems and carbonate producing organisms like corals and planktons. Okay, so it affects, say, because of some unnatural events, okay, that can happen, that can lead to uh, like complete disruption of the cycles of different carbonate producing organisms, okay, which those organisms, say for example like bivalves, brachiopods, which have their skeletons made up of calcium carbonate, their life affects a lot when there is a disruption in the CCD depth of a particular environment. Okay, now I'll show you what is actually how this look like. So I think you can see this. So you can see this is actually the this is the CCD that we were talking about. Okay, CCD or calcium carbonate uh, compensation depth. Okay, and this is actually the lysocline. And what is a lysocline? I'll tell you. If you are noting, then please note down the definition. A lysocline is the ocean depth where calcium carbonate starts to dissolve significantly. Okay, after which it starts to dissolve significantly, forming a transition zone between carbonate rich and carbonate poor sediments. Okay, so it actually marks the transition from the calcium saturation depth, that is CSD, above which the calcite is stable, to the calcite compensation depth CCD, which below which sediments are largely devoid of carbonate. Okay, so from 3 kilometer to say 4.5 kilometer, according to this diagram, you will see a decline of the calcium carbonate um, precipitation here. Okay, a decline will be there of calcium carbonate precipitation. Fine. So you can see this is actually the declining happening. There will be sharp decline here, and there will be no, after CCD there will be no calcium carbonate dissolution. Fine. This is actually the carbonate accumulation rate, the blue line. Okay. So that's why. So above lysocline, there will be complete carbonate precipitation. Below lysocline, there will be slowly, it will start to decrease. Carbonate dissolution will slightly start to enhance, and carbonate precipitation will start to decrease. After the CCD, there will be no carbonate deposition, only carbonate dissolution will happen. Okay, So lysocline is one important term, and CCD is another important term. Okay, this was a diagram. Let's go back.